Hello students, welcome to Jagannath Mathematics Tutorials. Today we are going to solve KEAM engineering solutions, right? So this is your first question. So let I equals to integration tan to the power 5x secant square x dx upon tan to the power 12x plus 1. Now you are given these 5 options. This is of the form MCQ, means single correct answer, right? So let's see how to solve it. For this, put tan x as say t, then secant square x dx is equal to dt, right? See, this secant square x dx will become what? This will become dt, and this tan to the power 5x will become t to the power 5, right? And this tan to the power 12x plus 1, this becomes t to the power 12 plus 1, right? Now see. I is equal to t to the power 5 dt upon t to the power 12 can be written as t to the power 6 whole square plus 1, right? Now next you put t to the power 6 as say u, then 6 t to the power 5 dt is equals to du, or t to the power 5 dt is equals to du by 6. So this t to the power 5 dt becomes du by 6, right? And this t to the power 6 is what? T to the power 6 is u. Put it here. This will be u square plus 1, right? Now this 6 is a constant, so it goes outside of the integration. See this solution over here. Now your I is what? 1 by 6 integration 1 over u square plus 1 du, right? And this is tan inverse u by 1 plus c. Why? As we know the formula, integration dx over x square plus a square is equal to 1 by a tan inverse x by a, right? So here in place of x we have u, in place of a we have 1. So the integration of du upon u square plus 1 square is equals to 1 by 1 tan inverse u by 1, which comes out to be tan inverse u only, right? Is this step clear to all of you? You can comment if you have any doubt, right? Now I equals to what? 1 by 6 tan inverse u plus c. Now see your u. U is t to the power 6, so replace u by t to the power 6, we get I equals to 1 over 6 tan inverse t to the power 6 plus c, where c is what? C is arbitrary constant, right? But t was what? T was tan x. So in place of t we will write tan x. So tan x to the power 6, right? Why? Since t is what? Tan x. Therefore t to the power 6 will be what? Tan x to the power 6, which is tan to the power 6x, right? So this is 1 by 6 tan inverse tan to the power 6x plus c is your final answer. Now check for the option. 1 by 6 tan inverse tan to the power 6x plus c. This first option is correct, right? Now let us come to this question number 2. First give it a try. So given I is equal to minus pi by 2 to plus pi by 2 cos square x upon 1 plus 2 to the power minus x dx. We need to find this value, right? Now see, 2 to the power minus x is what? 1 over 2 to the power x, right? Then this I is what? Minus pi by 2 to plus pi by 2 cos square x upon 1 plus 2 to the power minus x is what? 1 over 2 to the power x dx, right? From here we get this, right? Which further equals to minus pi by 2 to plus pi by 2 cos square x upon, now take the LCM, this will be 2 to the power x plus 1 upon 2 to the power x dx, right? Which is further equal to minus pi by 2 to plus pi by 2. This 2 to the power x goes over here, so this becomes 2 to the power x cos square x upon 2 to the power x plus 1 dx. Is this clear up till now? Right. So we have rewritten the question and we have formed this. Now check this. This 2 to the power x, we can add and subtract 1 from it, right? And cos square x remains the same. Now see, this will be equal to minus pi by 2 to plus pi by 2, 2 raised to the power x plus 1 into cos square x whole divided by 2 raised to the power x plus 1 minus cos square x upon 2 raised to the power x plus 1 dx. Is this step clear to all of you? See over here, this is a separate term, it goes and multiply with the cos square x, and this will be minus 1 into cos square x is minus cos square x, right? Now your I becomes minus pi by 2 plus pi by 2 this gets cancelled out, and this will be cos square x minus cos square x upon 2 raised to the power x plus 1 dx. Is this right? So by this property, if you have two functions fx plus gx from a to b, you can separate them like this. Right? We know this. So we have I equals to minus pi by 2 to plus pi by 2 cos square x dx minus integration from minus pi by 2 to plus pi by 2 cos square x upon 1 plus 2 raised to the power x dx, and name it as equation number 1. Am I clear till this point? Right. Now see, you were given the question this, right? This question, name this, say, as equation number 2. Now if you add 1 and 2, let me write for you the equation number 2. This will be minus pi by 2 plus pi by 2. This was the original question, right? This was 2 to the power x cos square x upon 1 plus 2 to the power x dx. This was our question. We changed it, and this we have got it. Now add this two. We add equation 1 and 2. So I plus I becomes 2i is equal to minus pi by 2 to plus pi by 2 cos square x dx plus minus pi by 2 to pi by 2 raised to the power x cos square x dx upon 1 plus 2 raised to the power x minus pi by 2 to plus pi by 2 cos square x upon 1 plus 2 raised to the power x dx. Right? Now what we need to do here is this. We use the property integral a to b fx dx goes to integration a to b f of a plus b minus x dx. Right? So in place of this, or you have, say, this is your I1, this is your minus pi by 2 to plus pi by 2, right? You have this as 2 raised to the power x cos square x upon 1 plus 2 raised to the power x dx. This will be equal to what? By this you add this 2, that is integration minus pi by 2 to plus pi by 2. This will be 2 raised to the power pi by 2 minus pi by 2 minus x cos square pi by 2 minus pi by 2 minus x over 1 plus 2 raised to the power, this will be a minus x only, right? So your this integral I1 will become what? Minus pi by 2 to plus pi by 2, 2 raised to the power minus x, and this is cos square, negative x is same as cos square x upon 1 plus 2 raised to the power minus x dx. Is this clear to all of you till now? See, your I1 becomes what? Minus pi by 2 plus pi by 2 cos square x raised to the power x dx equals to minus pi by 2 plus pi by 2. This is same upon, take the LCM again, right? Now see here, this 2 to the power x will go to the numerator, and this will change to minus pi by 2 to pi by 2, 2 raised to the power minus x, and this goes here, cos square x upon 2 raised to the power x plus 1 dx. Is this step clear to all of you? Right? Now this cancels out and becomes 1. Why? As 2 raised to the power of minus x is what? 1 by 2 raised to the power x, which implies that 2 raised to the power of minus x times 2 to the power x is what? 1. This gets cancelled out, right? So what you get, the value of I1 is the important part. So your I1 is basically from minus pi by 2 to plus pi by 2 cos square x upon 2 raised to the power x plus 1 dx. And you can see over here, what was your I1? This. So in place of this, can we write this? See it. So in place of this integral, we are going to write what? So 2i is equal to minus pi by 2 to plus pi by 2 cos square x dx, plus in place of this, in place of whole this, we are going to write what? We are going to write minus pi by 2 to pi by 2 cos square x dx upon 2 raised to the power x plus 1 minus pi by 2 to plus pi by 2 cos square x upon 2 raised to the power x plus 1 dx. Right? So you can clearly see that both these integrals gets cancelled out. Right? So what we are left with is so your 2i will be what? Minus pi by 2 to plus pi by 2 cos square x dx. Now since cos x is an even function, you may use this property. Right? Let us use this property. Twice integral 0 to pi by 2 cos square x dx. Right? This 2 and 2 gets cancelled out. We are finally left with integral 0 to pi cos square x dx. We change this to as integration 0 to pi by 2 1 plus cos 2x by 2. Right? Why? Since cos square x is what? 1 plus cos 2x by 2. So your integral half gets out. So your integration from 0 to pi by 2, 1 plus cos 2x dx. This is half x. Now the integration of cos 2x dx, as you know, this will be sin 2x by 2 plus c. Right? So this will be plus sin 2x by 2, and this x varies from 0 to pi by 2. Right? Let us solve finally. Put the upper limit in both the places. This will be pi by 2 plus half of sin 2 into pi by 2 minus, put the lower limit, 0 plus sin 0 is 0. So this is basically half pi by 2. This 2 gets cancelled out. This will be plus half sin pi is again 0. So this gets cancelled out as 0. We are left with half into pi by 2, which is equals to pi by 4. Hence our final answer is pi by 4. Let us check the option for it. This will be option number B. I hope this is clear to all of you. Let's move on to the next question, number 3. Here we are given if this is the greatest integer function of x square less than or equal to x square, then we need to find the integration of this. Right? So how to solve this? See, you know the greatest integer function, this takes only the integer values which are less than or equal to x. Right? So if I see this x ranges from 0 to root 2. If I draw a number line, say this like this, we have 0 over here, 1 over here, and root 2 over here. Right? So the greatest integer takes the values from 0 to the root 2. Right? So what we do is we first integrate from 0 to 1, and then we integrate from 0 to root 2. Right? You need to keep this concept clear if you are solving this type of questions. You need to know the meaning of this. So let I is this, so we integrate it from 0 to 1 x square dx, plus then from 1 to root 2 x square dx. Now in case of 0 to 1, if you see x square, where x is from 0 to 1, this will be equal to 0. It takes the lower limit. So put 0 in place of this, and in case of 1 to root 2, like here where x is from this, it takes the value 1. So put 1 over here. So this integral cancels out and this will become x, which lies from 1 to root 2. This will be root 2 minus 1. Option C is the correct answer. I hope this question is clear to all of you. Next, we have this question. We need to find the real part of 1 plus I over 1 minus I times 2 plus I over 2 minus I. Here you can have your two approaches. The first approach is either you multiply this with this and this with this and then get your answer, or you can do what? You can rationalize this individually. See, we can rationalize this individually also, right? See, this will be 1 plus I whole square upon 1 minus I square. This will be 1 plus I square plus 2I upon 1 minus minus 1. So this is 1 minus 1 plus 2I upon 2. This will be 2I upon 2 is I. So in place of this 1 plus I over 1 minus I, we can place I right from here. And if you see this part now, this is 2 plus I upon 2 minus I. We again rationalize it. This will be 2 plus I whole square upon 4 minus I square. This will be 2 square plus I square plus 4I upon 5. This will be 4 minus 1 plus 4I upon 5. This will be 3 plus 4I upon 5. So in place of 2 plus I over 2 minus I, we can place what? This 3 plus 4I by 5, right? So our question was the real part of this 1 plus I upon 1 minus I into 2 plus I upon 2 minus I. In place of this, we can place as I, and in place of this, we can place as 3 plus 4I by 5. Now you can multiply this. This will be 3I plus 4I square by 5. This will be 3I minus 4 by 5, since iota square is minus 1. This will be 3I by 5 minus 4 by 5. So you need the real part is minus 4 by 5. So your answer is D, minus 4 by 5. I hope this question is clear to all of you. Now next, move on to the fifth question. Given, let Z be a non-zero complex number such that Z equals to 16 over Z conjugate. Then they are asking you to find the locus of Z will be what, right? So 5 options are given to you. Let us solve this. We are given Z equals to 16 over Z conjugate. Now we cross multiply, then Z into Z bar equals to 16. Now by the property you know, Z into Z conjugate is equal to mod Z square, right? This implies this name as equation 1 becomes mod Z square is equals to 16, or mod z equals to 4, right? Mod z equals to 4. Now you know the definition of modulus of a complex number. So let z be a complex number, x plus iy, then your mod z is what? Root over x square plus y square, and you know your mod z is 4. Here mod z square, you take the squares on both sides, is x square plus y square, this, and from equation 2, from this you know that mod z is 4. Mod z square is 16. Why? As mod z is 4, then mod of z square is 4 square is 16, which implies that x square plus y square equals to 16, since mod z square was this x square plus y square. We place this over here, right? Okay. Now this is of the form x square plus y square equals to 4 square. Now this is the equation of a circle with center at 0 0 and radius equals to 4, right? Why? Because we know the form of a circle, x square plus y square equals to a square, where this represents the equation of a circle with center 0 0 and radius a, right? So here let's check the options for it. This is not a straight line, not a parabola, not an ellipse. Here they are saying any circle of a radius 4. So this is also wrong, because we have just found out that this is the equation of a circle with center at the origin. This is the criteria for it, and the radius is equal to 4. So E option will be correct, a circle with center at origin, right? Next question is this: if a square plus b square equals to 1, you need to find this value, right? Now how to approach this? Question? See over here, we are given what? We are given a square plus b square is equal to 1, right? If you factorize this, this will be equals to a plus iota b times a minus iota b is 1, right? You can check this. This will be a square minus iota b square equals to 1, or a square plus b square is 1, right? So this can be factorized, which implies that a plus iota b is equal to 1 over a minus iota b, right? Now with the help of this equation we are going to solve this. See now, we want to find 1 plus a minus iota b over 1 plus a plus iota b, right? So in place of a plus iota b, we are going to put this value, right? See here, this will be equals to 1 plus a minus iota b over 1 plus, in place of a plus iota b, we are going to put 1 over a minus iota b. Is this step clear to all of you? Then you may take the LCM. So the numerator is the same. This will be a minus iota b plus 1 over a minus iota b. Now this thing goes to the numerator part. This will be a minus iota b, and you are left with 1 plus a minus iota b over this is a minus iota b plus 1. If you observe a bit over here, you will get to know this, the numerator and the denominator are the same, right? So it gets cancelled out and we are left with the answer a minus iota b, which is the option A, right? Next, question number 7. We want to find 1 plus iota over root 2 whole to the power 2024, right? Okay, and a mod is also there. First of all, we check this part, right? See this part. This is 1 upon root 2 plus I upon root 2 whole to the power 2024. This is the mod, right? This is further equals to cos pi by 4 plus I sin pi by 4. Since cos pi by 4 is what? Cos pi by 4 is 1 upon cos pi by 4 is 1 upon root 2, and sin pi by 4 is also 1 upon root 2. So in place of this we have written this, and in place of this we have written this. Any doubts? You can ask me in the comment section. Whole to the power 2024, right? Now next, this is equal to, see, cos theta plus iota sin theta whole to the power n is what? Cos n theta plus iota sin n theta. We know this. So here my n is what? 2024. This is my n. So this will be cos, this will be cos 2024 into pi by 4 plus I sin 2024 into pi by 4. This will be equal to cos 506 pi. If you cancel this, 506 over here and over here as well, plus iota sin 506 pi. Now sine of any multiple of pi is 0, right? So this part is 0, and this will be mod cos 506 pi, which is equals to mod 1 is 1. So your correct answer is C, right? This will be the last question for today. Here we need to evaluate this integral. So let say I equals to integration x to the power 4 minus 8x square plus 16x times 4x cube minus 16x plus 16 dx, right? So can see that the differentiation of this is this. So you need to put x to the power 4 minus 8x square plus 16x as your u. Then 4x cube 16x plus 16 of dx equals to du. Right. So this part becomes what? Du from here, and this part over here becomes your u. Right. So you are left with u into du, which is equals to u square by 2 plus c, where c is an arbitrary constant. Now this will be half, and u is this x to the power 4 minus 8x square plus 16x whole square plus c. So now you can check the option. I think the option is C. That's it for today's session. You can like, share and subscribe to my channel, and you may share this video to all the future aspirants of KEAM.